Hi. Unmute.
Can you just start sharing some screen before Rupam comes? Just we can check, see if we can able to share some PPT or some document.
Host disabled participant share screen.
Host,
Disabled participant screen sharing.
make co-host. Try now.
Okay, anything, no?
Try now.
You can see my
Yeah,
screen.
yes, good. Okay, you can unshare the screen now. Let us wait for Rupam. Please unshare the screen.
Stop sharing. Okay, pause.
Unshare the screen. It's
Stop
coming.
sharing.
It's coming. Yeah. So let us wait for Rupam.
So that link is okay, right? Google form.
Yeah, it's okay. It's okay.
So when are we like posting that link?
That is after the presentation. Then we can post the link. I'll let you. I'll inform that. I'll announce that.
Okay,
Okay,
7
Rupam
attendees.
has come. Rupam has come.
Okay.
Okay, I'll promote him to panelist and ask him to share the screen and stand by for the time. Good evening, Rupam. Welcome.
Actually, his video, audio is on. Yeah.
Can you hear me?
Yeah. Yes, sir. Yes, sir.
Yeah. Good evening, sir. Can you try to share the screen just for check everything?
Yeah. Yes.
I think some problem in audio, it seems.
Can you hear me?
There's some problem with your audio, Rupam.
I'll see the setting.
Some background sound, something. Some
I see the sound actually.
overpass.
Yeah, screen is coming. If you can go to the presentation mode. Yeah, sir. Can you change the slide, sir? Go to the next slide. Yeah, I think slides are moving. No problem. Next one. Yeah. Okay, sir. Come to the first slide. Slide is moving. Only problem with your audio, sir.
Just. Yeah. Is it all right now?
Yes, I think it's better. There's some background noise is there in your audio.
Still.
Yeah, maybe some headphone you can put.
Yeah, headphone I have put actually.
Okay.
Yeah.
Can you share your video, sir?
Yeah. Yeah. Hi.
Hi.
Hi, sir. Hi.
Yeah. Welcome.
Oh, nice. Good evening. Good evening.
Good evening. Good evening. So it is from your office?
No, we are at home. I am at home.
At home. Okay. Yeah. So how many people are participating?
We are circulated. I'm expecting maybe about 200 people, maybe more, 300. I don't know. Maybe we just look into some 5 o'clock, and then I'll can see
Yeah.
the screen.
Yeah. So we'll start the presentation. So you will introduce me or
Yeah. Initially, I'll just introduce you first and
Introduce me.
hand over the floor.
Yeah.
you can start presentations. Then once you conclude, then what we will do is we will send that Google form on the chat. All the participants can click and send their feedback and the contact details. So for those who have registered on the Google form, we will try to share this presentation link to them. And at the end of the presentation, all the participants can post their questions on the chat. You can view the questions and you can answer them. Once you have finished it, we will conclude by the end of next.
So they will put the questions in chat, or they will...
Yes, sir. Yeah. Because this is a webinar, no, we cannot have everybody on.
Yeah, there is one Q&A session, is there, question and answer. So the questions will come there and you can discuss.
Okay. So I can probably answer those questions.
Yeah. You can answer those questions, sir. You can read those questions and answer those questions. Finally, our secretary, Professor Anbalagan from IAC, he will just have a quick vote of thanks and we can conclude.
Okay, fine. So we'll conclude with 1 hour.
Yes, sir. 1 hour.
Absolutely, yes.
You can have your coffee leisurely, sir. We will stand by for 10 minutes and come back 5 minutes before 5 o'clock.
I have finished, not a problem. Yeah. Link to establish session. Link to establish session. Sir. Mungkin ke single din. Ke single din. ठीक है सर. फोन को दिन पे.
Welcome, Professor Anbalgan.
Yeah, so I log in.
Yeah. Welcome, sir.
Okay. Just mute the mic.
Yeah, sure. We'll just start in a few minutes. Many people are joining.
So, Partha, our executive member, none of them are there, huh?
I think there are few of them as attendees. So, some of them are there. I think they are still joining.
Chandrasekharan is there, VS.
Yeah.
Sir, it's time. I think we can
Yeah.
start 5.
Now we'll wait. Anybody expected? Somebody?
No, they keep joining. We don't know how many will come. So I think on time. So we can just introduce Rupam and we'll start. Already
Yeah, okay.
Yeah. So good evening to all the participants. On behalf of Indian Geotechnical Society Bangalore chapter, I welcome all the participants. At the outset, it's a great pleasure to have Mr. Rupam Mahanta as a speaker today. Welcome you, sir, on behalf of the IGS Bangalore chapter. I'll just give you a brief about our speaker. Mr. Rupam Mahanta is the General Manager with ONGC, Oil and Natural Gas Corporation Limited. and he graduated in civil engineering and post-graduation in soil mechanics from Assam College of Engineering, Guwahati. He started his professional career in 1993 as a civil construction engineer. Subsequently, has been working in the area of offshore geotechnical engineering for close to more than nearly 2 decades now in the areas of offshore geotechnical investigation, offshore foundation analysis, and life extension studies for ONGC offshore platforms. Currently is posted at Institute of Engineering and Ocean Technology, that is IEOT, which is an research arm of ONGC. Rupam Mahanta has authored more than 20 research papers for national and international forums on various aspects of offshore geotechnics, such as offshore pile analysis, investigation, jackup rig foundations, CPT-based pile capacity, etc. He himself is a computer program and has independently coded a few offshore geotechnical programs, such as CPT-based pile capacity as per the API method, leg penetration analysis and punch through analysis for jackup rigs, mud mat bearing capacity, axial load movement of pile based on nonlinear TZ data, nonlinear PY data based on API recommendations, etc. And some of his programs are officially used for ONGC's geotechnical works. Mr. Rupam is also a member of TZ 304 of ISSM GE. Has been associated with a joint industry research project on CPT-based pile capacity, which is operated by Norwegian Geotechnical Institute, and he has worked with the NGI expert in Oslo on this project, representing ONGC for nearly more than 2 months. He is also the winner of Innovation Award, which is an individual award for the ONGC represented employees and directly awarded by the CMD of ONGC. With a brief introduction, I will hand over the floor to Rupam Mahanta to continue his presentation. Rupam, the floor is yours, sir.
Thank you, Dr. Patasarati. I welcome all of you to this presentation. I'm happy that I was invited from IGS Bangalore chapter through my good friend Dr. Patasarati, and I accepted his invitation immediately because this area needs focus and development within India. And the topic was offshore pile capacity, soil pile interaction, and group effect. First of all, I hope that all of you, along with your family, are safe and protected against the current pandemic. So this is the way we have to develop our knowledge on various aspects and utilize our time properly. So without spending much time, I will start the presentation. Offshore pile capacity, soil pile interaction, and group effect. So this screen shows the offshore platform complex in the Bombay offshore, where we can see different kinds of platforms, and all these platforms have the permanent foundation as pile foundation, and that's why offshore pile is so important, because in the design of any platforms, we need to have the capacity assessed first, and the pile configuration, numbers, depth of penetration, everything depends on the pile capacity. And that's why this is so important and fundamental to the design of any offshore platforms and its foundation. On the top right figure, we have shown that how the environmental forces and the self-weight of the structure affects the foundation, and how the foundation needs to resist all these forces. On the bottom left, standing myself in a construction installation of platform. This was in Mumbai High a few years back, and that is a hammer which was used to drive the piles for the platform. So this is an introduction to the offshore piles. All our offshore piles are open-ended tubular piles which are made of steel, and that acts as a permanent foundation for all our jacket platforms, as already have been said. And the typical diameter of these piles are 1.21 meter to 2.44 meter, that is 96 inches. Even larger diameter are being planned for new platforms, and the bulk thickness of the piles are generally 25 to 100 mm. And generally the length for our Indian offshore is typically 50 meter to 150 meters below the seafloor, and all are driven by hammers. And axial capacity, soil pile interaction, and group effect are essential parts of the analysis for design, even for analysis of the existing platforms for their safety. Now, this is a simple schematic which shows the two types of piles for the jacket platform. One is main pile, which is driven through the jacket legs, and another in the red color is the skirt pile, which is on the side of the main jacket structure, which is connected through jacket sleeve and the frame tubes and plates to the jacket structure to transfer the load of the jacket to the piles. And all skirt piles are grouted, whereas the main piles may or may not be grouted, but the Indian practice here is that we grout all the piles with the jacket legs. Now, there may be different configurations of these piles. For simple platforms like this four-legged platform, which is on the left side, so there are 4 piles here, and 2 are single-bettered, and the other 2 are double-bettered. Sometimes there will be both skirt piles and main piles together configured for a platform, and sometimes platforms are configured for foundation with only skirt piles. So it depends on the situation, the load of the structure, the water depth, and design of the jacket, and purpose for which it is built. So one question will arise why these are single-bettered, because we drill our wells in the platforms, wellhead platforms, by using jackups, and jackup approaches this platform from this side. So it is north side in Western also, and that's why on the north side mostly this legs are single-bettered, so that there's no interference with the jacket legs, the piles, so they clearly away from the jacket legs and the Spartan foundation. So in heavy platforms, there will be cluster of piles, so there will be groups, especially in areas like North Sea, Gulf of Mexico, where the production of oil is very high compared to our Indian offshore. And then many piles are clubbed together as a group. So then analysis becomes even more cumbersome and more rigorous analysis is required, including group effects. Now we come to the axle capacity part. So as we find in onshore piles, there are 2 components. One is skin friction, the other is end bearing. So these 2 resistances combined together to give the axle resistance for the pile. And skin friction is the main component, and end bearing is a lesser part for offshore piles because piles are very deep. And there are 2 cases for the compressive loading. One is plugged case, one is unplugged case. So the external skin friction or sub friction is always taken for any pile, and the end bearing for the annular wall area is always taken. Now, there are 2 other parts. One is the inside skin friction. That means the skin friction of the soil plug with the pile wall, and end bearing of the soil plug. Out of these 2 components, whichever is lesser, that is considered in the capacity. So ultimately, if the end bearing of the soil plug is less than the skin friction of inside skin friction, then this pile is plugged pile. Otherwise, the plugged pile is considered as an unplugged pile. So whatever is lesser, that is considered. So now the question is that whether the piles are plugged or unplugged when it functions as the permanent foundation. So in long term, all our piles are functioning as plugged pile, because after driving the piles, when the soil consolidates and with the edging, the skin friction inside the pile becomes very high compared to the end bearing part of the soil plug. So the mode of failure will be that when you push the pile, suppose for failure, the pile will shrink along with the soil plug. So that is a plug pile. However, during driving, most of the piles, because they are not diameter, and there's dynamics of the driving, and soil gets remolded, and there's an inertial force also, the piles normally are driven in unplugged condition in most of the cases for large diameter piles. In tension, we do not consider the end bearing because it is not permitted by the codes. We consider only the side friction or skin friction. And in deriving the factor of safety for the piles, we have to consider the self-weight of the pile, including the soil plug. Now, these are the formula which are considered, which are recommended by the API code, and API code is mostly followed, especially in our offshore and in many places, including Gulf of Mexico. So these are the main text formula. So we can find in sand, which is like the onshore piles, beta into sigma 3 naught dash, that is effective overburden stress at any level. So the skin friction is related to that. Earlier it was K10 delta into effective overburden. So they have replaced this K10 delta with the beta factor. And in case of clay, this skin friction is calculated with the alpha method. Alpha is a factor, which is again calculated with respect to the strength ratio, that is undrained shear strength divided by the effective overburden pressure. and maximum value of alpha can be only 1.0. So if it is more than 1.0, it has to be limited to 1.0 only. Regarding M-pairing, in case of sand, the effective overlapping stress is multiplied by the NQ factor. And in case of clay, it is 9 times undrained shear strength. One thing is that in the main text formula, in case of sand, there are limits for maximum skin friction as well as embedding. So those limits are to be followed during the assessment of pile capacity. And a change was done in case of this formula. In case of loose sand, very loose sand, and sand silt. In these cases, the CPT-based values are recommended to calculate the embedding as well as skin friction. So earlier, there were values recommended by code APRP2 for this kind of soils also, but now it has been removed. So this for very loose soil, loose sand, and silt, CPT-based formulas are recommended. So this is table for soils which are recommended. This is medium dense sand and medium dense sand silt, then dense and very dense sand silt. For this, the values are recommended by the APRP2 code, which is the latest code, and beta factors you can find out here. And if we compare with the earlier RP code, APRP code for the pile design, the beta factor, comparing this beta factor to K10 delta, then we find that the K factor is 0.8. So if you multiply with the 0.8 and the appropriate friction angle of the original code, you will find the beta factor. And the limiting skin friction is from 67 kilopascal to 115 kilopascal. In case of embedding, the limit has been set as 3 to 12 megapascal. Now, in capacity, even if we calculate the capacity by cumulative sum of the external skin friction and considering plug unplug behavior and the end-bearing of the pile pit, even then some modifications are required to find out the refined capacity, because the code recommends that if we encounter a hard layer near a soft layer, so this is a clay layer, and from clay to sand we are entering, so suppose pile penetrates this layer, sand layer, then the capacity suddenly, it does not suddenly increase, it has to be gradually increased actually. We just do 3 pile diameter. In ONGC, we recommend that 3 pile diameter transition is required. From bottom also, if the pile we penetrate, if we just keep the pile just above this clay layer, this is a clay layer and this is a sand layer, so the capacity will not remain like this. It has to be modified, this has to be reduced, and this transition has to be applied because the tip of the pile will sense the presence of the weaker material. That's why, for safety, 3 pile diameter above only, the full mobilization is assumed, otherwise it is modified. And finally, we have to also consider the scour. In axial capacity, scour does not have much of an effect because the initial soil layers are anyway weak and the scour depth is very limited compared to the total depth of the pile. And even then, that is to be considered. It is more important in lateral than axial. And pile and soil plug weight, that is also to be considered to find out the net capacity, net ultimate capacity of the piles. Finally, we compare the factor of safety, and factor of safety is recommended as 2.0 for operating condition and 1.5 for extreme environmental condition. So extreme environmental condition is 100 years storm return for an offshore, and that is considered, that load is considered for the design of the structure and the pile. For jacket platforms. And for other structures, it is different. Like for jacob 50 years storm is considered. Now, we have discussed about the main text formula for the axial capacity. Now, recently, the CPT-based pile capacity has gained importance because of more scientific nature of assessment of the CPT-based methods. So, many institutes have come out with their recommendation for the CPT-based pile capacity. However, the API in recent editions considered for sand, for pile capacity in sand. So these 4 different institutes are ICP, that is Imperial College of London, and UW means University of Western Australia, then FUGRU is a professional geotechnical company, then NGI, Norwegian Geotechnical Institute. All these 4 formula have been considered by API and recommended for use for sand, siliceous sand. And 3 of these methods have common type of formula. Of course, the coefficients A, B, C, D, all these will be different but the pattern of the assessment is same. So this formula has been listed. I will not explain each and every term, but you can see that it is basically depends on the QC, that is the cone resistance of the CPT. CPT means cone penetration test, that tool that has a cone, and that cone resistance is recorded during investigation of soil using that CPT. So that QC is directly used for calculation of this thing. And AR is dependent on the wall thickness and diameter of the pile, area ratio. And for NGI, the formula is a little different, and that's why it is listed here. So, and regarding embedding also, they have recommended different kinds of formula. For example, ICP has given a formula, and minimum embedding has been recommended as 0.15 times the QC average. So this is also very important. QC average means the cone penetration resistance averaged within 1.5 diameter above and 1.5 diameter below the calculation of the QC average. And that is applied to find out the unit embedding of the pile. And for FIBRO also, it is a different formula, and NGA also has given the formula. This is EWA, and NGA formula is this one. So, I'm happy to inform that I could develop one computer program to calculate the skin friction and bearing and capacity as per the KRP2G, and based on that, we calculated the capacity, which applying different methods for different kinds of sand, and it is ideal sand actually with the same density throughout the depth of the pile penetration. For medium dense sand, which differences in pile diameter, these are the differences actually. So we can see that if the sand is medium dense or loose or very loose, the API direct method that is in the main text gives a higher capacity. And that may be the reason why the recommendation of the direct method is put off for the loose sand and very loose sand and medium dense sand silt also. So, sorry, loose sand silt also. And in case of very dense sand, the API method which we have been using comes, the result is in between the results given by the other methods. So it is all right, and it is shown that the CPT-based methods also give the similar results. And another aspect is that the differences between different methods, CPT method and the API main text method, has a lot of difference. And that may be the reason why the API has not recommended any factor of safety specific for these methods, like it is recommended for the main text method. So judgment is required to apply this. So the factor of safety applicable for these methods actually depends on the probability of failure of the foundation, and that is a reliability based analysis. And JIP, which was mentioned by Dr. Bhattacharya, as I was also participant, and still another JIP is going on. There, the factors of safety for different methods were derived based on case-to-case basis, based on the soil data. So the quality and reliability of the soil data. When we calculate the pile axial capacity, we present it like this. There is a compression graph, there is a tension graph. Tension graph is on the lower side because the end bearing is absent in case of the tension graph, and the compression graph is on the right side. We can notice that there are some enlargements in the graph, like here at the end of the tip of the pile, because these are sand layers where the end bearing is higher. So mostly in our platforms, the piles are targeted to be tipped in sand layer. Not only from capacity point of view, from load deformation point of view also, it is a safer kind of practice to place the piles in thick sand layers. Now we're coming to lateral load resistance. So lateral load resistance is very important in the design of piles, because the lateral load resistance analysis gives the pile displacement subject to loading from lateral direction. And finally, we get bending moment and stress in the steel, which should be safe and within allowable limit as permitted by the code. And one thing is that for all offshore piles, these are long flexible piles. Other piles are rigid piles, which are short piles. So failure modes are different. That is known by geotechnical engineers. So in case of offshore piles, if it has to fail, it will fail in structural mode only. That means plastic hinge will be formed in the body of the pile, and that way it will be fail. Not that the bottom of the pile will rotate. It will not rotate. So it will remain stationary. Pile will fail in the near sea floor. Up to certain depth, the chance of failure is there if it is subjected to extreme load. And the fixity point at some depth can also be determined by analysis of the load deformation of pile. So that is also important if we replace the pile and replace it with some spring for dynamic analysis. So this kind of analysis is required prior to doing the dynamic analysis. Now, soil near seafloor is very important for lateral resistance because in case of soft clay, we find that for a particular load, say 4 meganewton, is applied on a ops pile, then if it is soft clay, the deformation will be quite high. And if it is stiff clay, it will be relatively less. However, there is another thing. In case of stiff clay, because we apply the cyclic PY data, there are two types of PY data. One is static and cyclic, because the offshore foundations are of cyclic in nature, loads are in cyclic in nature, so cyclic data is recommended to be used. So in case of stiff clay, it may be very brittle nature, and after peak, the degradation will be very high, especially if we use the ridge atoll method for stiff clay. In case of sand, it is quite good, resistance is quite high compared to soft clay. And load deformation analysis is also important from the point of view that we cannot allow the lateral displacement to be exceedingly high because there will be limitation of equipments in the platforms or other structures. So the lateral displacement has to be limited, and that's why this analysis is so important. So if we continue to load the pile on the lateral direction, so the graph will be like this. So here we have not assumed the failure of the pile, assuming that the strength of the material is very high. So if we apply the load, it will go like this. So now this was 84-inch pile for a typical offshore site. Here the displacement will be limited because the load, maximum load from the extreme environment will be around 4 or 5 meganewton. So the displacement is quite limited. However, if we see the capacity of this pile, it can be taken to very high level. Now we are coming to the next part of the presentation, that is pile-soil interaction. So what is pile-soil interaction? Because capacity we can calculate externally without using the TZ, QZ, and PY data, for which we will show graphs. These are the load deformation data of soil, the soil springs in impact for the model. The deformation of supporting soil causes changes in movement, stress, displacement, etc. in the pile, and response of the soil at different depths also changes as per the displacement of the pile. The soil behavior is non-linear, and the pile material behavior is assumed as linear in the design level analysis. So this non-linear linear analysis is combined actually. Material property is combined in the analysis, and displacement at a depth also affects the response at other depths. Finally, for a particular load subjecting the structure, subjected to the structure, there will be an equilibrium. And this interactive analysis give the final forces, displacement, stresses, etc. So that is the result which is used for the design. And if it is not safe, then configuration has to be changed or load has to be reduced. This kind of approaches are done to refine it. Now, what is the input required for the interactive analysis? One is that pile data, that is the pile material property has to be input in the analysis. The geometry is required, diameter, wall thickness, and the pile heads are then linked to the soil data and the structural nodes, and pile beta are defined so that the actual inclination of the pile with respect to vertical is defined in the input. So normally commercial packages are used for this interactive analysis, like SACS, SESAM. SACS is a Bentley software, and SESAM is a DMS software. So both are used for this kind of analysis. And soil data has to be used in terms of springs, like Excel springs. These are TZ and QZ. So TZ is the soft friction part, which is input in various levels along the length of the pipe. And QZ is one spring that is at the bottom of the pipe. PY is lateral spring, which are input at different depths. So normally 1 meter at every 1 meter, we put one spring depending on the soil character. So that PY represents the soil characteristic with respect to lateral node deformation. And also some softwares like SACS gives the facility to input the basic data of soil, where the shear strength of the soil, like the SU, undrained shear strength or friction angle, limit weight, etc., friction limit, bearing limit, all these things can be input, and then the TZ, QZ, PY will be automatically generated and analysis can be done. However, user-defined input, because we can take care of scars, etc., and if the method is slightly different depending on the offshore site, localization of the method, then we have to do the user-defined input. And torsional spring data is also input as one line. That is not very important, of course, we have seen. And scar data is also very important to be input. So in case of scar, we normally take initially 1.5 times the diameter of the pile as the scar depth as a thumb rule in the initial design, if there is no other data. So when the existing platform is analyzed, we have a survey got done, and based on that survey, we find out what is the actual scar pattern. Accordingly, we deal with the situation. Now, this is a typical screenshot from the SACS input. You can see the top lines are the pile basic data, like the diameter here equals 48 inch pile, 1.219 meter, and these are wall thickness 38 mm, 50 mm this way. And different piles, if they are different, then groups are input like this. And then the piles are connected, also linked with the soil data. We can input not only one soil set, there may be different soil sets for different piles, because in case of a large platform, if we have more than one borehole and we get different soil data, so we can take care of that situation in the analysis, and that will be a better and refined analysis. So TZ and QZ also, we have shown only 1 or 2 lines here, but there will be many lines, because every 1 meter depth will give PY data, and TZ also every layer change we give, and QZ also certain depths we input, because pile depths will be different for different piles in the platform. So in that case, one set of QZ data should take care of all the piles. Respect of pile capacity, Excel capacity, that reduction of pile Excel capacity. The Excel capacity we calculate based on the main text method may not be the correct Excel capacity in case of certain situations. And that is also commented, given by the API and other codes. So one needs to be careful in designing pile that the ultimate capacity calculated just by the formula may not be correct actually. So one of the things is that continuous shearing of soil during driving. In case of sand, there is a friction term called friction fatigue that is not accounted by the main text method. However, the CPT-based method takes account of this friction fatigue, and if you see the friction pattern in case of CPT-based methods, then you will find that the skin friction changes at the depth. If we increase the depth more, then the skin friction will further reduce. If we increase more, skin friction at a particular horizon will further reduce. So initially it will be higher, then it will be reducing. And finally, the pattern will be like that. The skin friction at the near the end of the pile is very high, and skin friction at the top is very less. So conventional API text method does not take into account this effect. Then elastic compression, self-compression of piles. So the deformation is also important in case of foundations. Of course, in offshore, the deformation is not so important as it is important for onshore structures. All of our structures are steel, and the equipments in the platforms can tolerate a lot of displacement. The structure also can tolerate because it is a steel structure. So in our case, the deformation is not very sensitive to the performance of the structure. Then progressive failure of soil zones, because it is a deep pile, so all the skin friction along the shaft of the pile will not be mobilized at the same time when we load the pile. And that's why the top, if the pile goes into failure, the top soil layers will fail first, and then the failure will come to the bottom. So this progressive kind of failure can happen. And in case of clays, we see that post-peak there is a degradation of the shear strength. So that post-peak degradation comes into effect if the deformation of the pile is more. If the pile is displaced more by the load, the soil, in some soil layers, the skin friction will be past the peak. So in that case, there will be degradation, and API recommends a degradation up to 30%. 10% to 30%, that is recommended. So if we consider the peak, suppose you do 1, then post-peak it may be up to 0.7. So there is a reduction in the capacity. So that's why other layers will be having more loads, and if they also fail, then there will be progressive failure. In case of large diameter piles, as we have shown already, that there is a requirement of sufficient penetration in hard layer. Suppose we take the pile in sand, and the sand has a very good property. However, it is just there very weak soil. In that case, the pile tip will sense the presence of the weaker layer nearby, because these piles will plug the pile with the long-term static capacity, and that weaker layer will reduce the end bearing. So that way, the capacity will be reduced. Secondly, just after driving, UD means end of driving, because piles are driven during installation. Installation is by driving. So at the end of driving, the soil will be removed, and the capacity of the pile is much less than what will be the long-term static capacity. So the API formula is for the long-term static capacity with the shear parameters tested in laboratory as well as derived by other tests like CPT, etc. So UD capacity is lesser, much lesser than the long-term capacity. So one need to examine whether the installation of the structure with all facilities is okay with the end of driving. However, in 2-3 days, the capacity increases quite good because of the setup of the soil, especially clay, and we gradually get a very good capacity. And within 2-3 months, we almost get the full capacity as expected. So this is about Excel interaction. The practice is that we model the soil as nonlinear springs, that is to PZ and QZ data, and pile as linear elastic spring with the structural properties. And the pile is divided into segments, and it depends on the software how much it is well optimized what is the segment length to be considered for the analysis. I have developed my own program also and tested it with stacks, and it is giving the same result. And the soil is divided into layers. So normally we give the TZ data at every layer change. So intermediate depths at which TZ is required, that will be considered by the software by linear interpolation. And Excel load is always transferred. If you push the pile, that Excel load will be transferred from the top to bottom. First, the top soil will get the stress, and then gradually it is coming to the bottom. And NPRing is like a insurance actually. It is the working condition of the pile. Normally, the NPRing of the piles are not activated. So mostly the load is borne by the skin friction, but that is a safety. And if the pile is pushed too much by overloading, etc., so the NPRing will come into effect, and it will help in preventing disaster. So this is the mechanical model actually. This schematic shows how the springs are modeled. That means these are TZ data. These are TZ data on the side, and this is the pile springs. And at the bottom, there is a QZ spring. So these are soil data. These are steel data. Now, if we push it, then we can find out finally for every load we can find an equilibrium, and we can find out the shearing shared by the pile body and the compression of the pile also. So the practice as per the API is that the full end bearing is mobilized when 10% deformation takes place at the bottom of the pile. And in case of skin friction, it is the 1% of the pile diameter at which the peak is reached. However, that is not a fixed thing. So it may be up to 2% also, it depends on the situation. But the thumb rule, and if there is no other guideline, then 1% slip is required to mobilize the full skin friction at any particular depth within the pile shaft. So this is the pattern of the TZ graph recommended by API. So in case of sand, you can see there's no degradation of the peak. And in case of clay, post-peak degradation is shown, and that has already spoken. 0.7 to 0.9 times the peak value is to be considered for this part. So if we push the pile too much, so it will come to this side, and then we will lose some strength of the clay layers. This is the QZ graph. For sand and clay, the pattern is same. and there is no degradation after the peak because it is limited actually 10% at the 10% deformation. The maximum value of the n bearing is assumed by the codes. However, it may not be true practically, but we have to follow the code, and then this may be the bindings from the package also. Accordingly, we have to go ahead. And this is the result I have shown how the program developed by me is matching exactly with the SATS software. So this is the load evacuation by a pile. If you put the load, it was slightly more than 50 meganewton was applied, and how the load is distributed. We can see that most of the load is shared by the skin friction part, and the end bearing is just very less. So what we find for the offshore piles in Indian offshore, the end bearing part is around 10 to 25% in most of the cases, and the rest is shared by the skin friction. So soft friction is the main part. So this file was 2.134 meter, that will be 84 inch, and wall thickness was 25 millimeter. Now, if you see the axial load displacement of a pile, then this kind of graph will get. So we can see the axial deformation in the design, we get very less quantity, say 5 centimeter or 10 centimeter kind of deformation we get for the extend load, because this is the reason. Because suppose this file has ultimate capacity of approximately 50 meganewton. So during extreme storm, it will be like this here. So here the deformation is just about 20-25 millimeter. So that kind of deformation we get actually when we apply the load. So for failure, it has to move too much actually. So in this case, it will be 250 mm. Now we are coming to the pile lateral solution for the interactive part. So practically, all offshore piles lateral solution is done by the beam on elastic substrate that we call popularly known as sprinklers approach. And the soil reaction springs are represented by the PY data. Already has spoken a little bit about PY data. And pile stiffness is represented by the E into I, Young's modulus into moment of inertia. And this is the basic equation. This is a fourth order differential equation, and the solution of which gives the solution of the lateral loading of pile. So that solution is normally obtained by finite difference method in the commercial packages. There are other approaches like 3D finite limit also is possible. However, for practical purposes, it is not recommended and not possible also for every case to do 3D finite limit. And person to person it will differ. However, if we do the PY kind of analysis, every person, if he or she does it correctly, the result will be same. So that is recommended by the code. So schematic is like this on the right side. If we apply lateral load at the pile head, these springs will be the springs which will resist this pile movement. So these are PY characteristics represented as mechanical spring. So spring, and in the input data we will give diesel data. So these are all discrete springs not connected to each other, uncoupled, and pile deflection, shear, and bending moment will be obtained as a result of the analysis, and the bending moment which is obtained, that will subject the pile to structural stress, and that stress has to be checked against the allowable stress for the pile material. Then it is safe. Otherwise, we have to redesign. And there are procedures, different procedures for different kinds of soil. Like soft clay, there is a procedure, regional method. Metal method is recommended by the API code. And for stiff clay, there is different method. And stiff clay, the difference in the method is recommended by API to be followed when the undrained shear strength of the clay is more than 100 kPa. Then you have to follow the stiff clay method. Otherwise, if it is less than 100 kPa, then we have to follow the soft clay method. And for sand also, for sand it is O'Neill marcation method, which is followed by API, recommended. And we also follow this when this. So there are differences based on the depth and the cyclic or static nature of the loading assumed for the analysis. So at different depths for a typical offshore site, we have shown the PY graphs, how it comes. So just here we see that at 0 meter, you can see after certain deflection, it will be just like zero strength actually. And it will be like this because there is a reduced resistance zone below the seafloor where we analyze the PY for the soft clay. If you go to the API document, then it is written very clearly. The method of MATLAB, in that method, we find that there is a reduced resistance zone where the PY pattern is different. So accordingly, we have to generate the PY data. And in case of stiff clay, this is the graph which is as per the Ridge et al. Method. So these were developed based on actual field test and semi-empirical kind of method. We can see this was actually for stiff fissile clay, so that's why after peak the degradation is too much. In case of sand, the PY graph is like this. This was for a pile of 16 outer diameter, 1.5 to 4 meter. And at 23 meter, we got this kind of graph. So P is given in the unit magnetron per meter. Per meter is the length of the pile. And what is the lateral deformation of the soil. Now, if we analyze a pile with purely lateral load, then we will find this kind of patterns of bending moment. That means we can see this is a fixed headed pile. That means the pile head is restrained with respect to rotation. And most of the heavy platforms, jacket platforms, when there are multiple piles, the superstructure, that is the jacket, restrains the piles from rotation, even if it is not fully fixed. So fully fixed is the ideal condition. It is very highly restrained. So we get the pattern of the bending moment like this. So there is a negative bending moment because of the fixed end moment. And in case of free-headed pile, if this is a free-headed pile, there is a moment only lateral load, then we will get the pattern of the bending moment like this. So this is the depth actually where the stress is coming from the lateral loading. So it is not for the full depth, it is limited to certain depth below the seafloor. So because of this kind of high stress near the seafloor, piles are normally designed with different thicknesses, because throughout the depth, if we keep the same heavy thickness, it will be very uneconomic, and the pile material consumption will be very high, and installation cost will also go on, because pile sulfate itself will be very high. So the practice is that in offshore pile, wherever whatever thickness is required, that is given. So it is optimized to reduce the cost as possible, as well as possible. And if we say deflection, the lateral deflection will be like this with respect to lateral loading. So in case of fixed headed pile, it is highly limited because of the restraint at the top against rotation. And if we make the pile free headed, for the same load, it will be like this, more than 4 times the lateral deflection. Regarding scour, because scour is also very important, because scour, not in axial capacity, but in lateral capacity, this scour consideration in the analysis is very important, because it can change the pile stresses, the deflections, and if the design is a margin, then the design has to be revised. And we also face situations where initially this cover was considered less, and afterwards, after say 10-15 years, we find that this cover is very high. We have found cover even up to 7-8 meters in some locations in western offshore of India. So if these are not taken into account in the initial design properly, then afterwards it becomes very difficult to prove that the platforms are safe in place condition. So that's why we had a parametric study on scour, how it affects. It is found that these are given that without scour, in case of clay profile, in sand profile, all these are shown. And these graphs are sand profile, and this dotted are clay profile. So in case of sand, the lateral resistance is normally high. So even if scour is there, the bending moment and deflections are limited. In case of clay, it is definitely high. And how it changes the displacement and bending moment is from here. Now we're coming to the end of this session, the last part, that is pile group effect. So group effect is one of the very important things, because the API code which is followed for design or any big package of any companies like our Manchester, we recommend that the group effect needs to be accounted for if the pile number is more than one pile and they are closely spaced. So 2 pile or more number of piles close to each other, requires a group effect analysis. So what the group effect analysis, there will be axial and lateral. Both have to be analyzed. So API recommends that if the spacing between two piles in a group is less than 8 diameter, then the group effect needs to be considered. However, the axial group effect is not very critical in most of the cases if the spacing between two piles is more than 3 diameter. However, in case of lateral group effect, it is important and needs to be looked into, and it can become a sensitive issue if the margin in the design is less. Then we may be in problem actually if we properly do the analysis. So this group effect analysis is important. So we'll definitely focus on the more on the lateral group effect. So what happens actually in group, why the pile in group goes into higher deformation compared to single isolated pile for the same lateral load, because the stress zones between piles overlaps, and that's why the deformation is more. There is shadow effect in case of lateral loading, and so lower capacity per pile is found if we analyze. So displacement is higher for the same average load. And API happy to, as we have already spoken, that if the spacing from pile to pile is center to center is less than 8 diameter, then the group effect is to be accounted for. So in case of axial group effect, the API does not recommend any particular method, but for lateral group effect, the Fock and Coates method 1973 with some modifications that is recommended now. So in case of axial group effect, there are two aspects. One is the capacity reduction. If it is found that the capacity of the group is reduced, then you have to make reduction in the axial capacity of each pile of that group, and the factor of safety has to be obtained as per the required limit, that is 1.5 and 2 with that reduction. Another aspect is that axial load deformation aspect. So because of the group effect, the load deformation aspect will change, and that change needs to be incorporated. However, the axial part is not very sensitive. Lateral part is more sensitive. So the axial part is taken care by the two aspects. One is capacity reduction by various methods, by block method of Tajiki or Pulas interface, etc. And Z factor is applied for the TZ data based on elastic approach of Pulas. It is okay. And in case of PY data, we have to modify the PY data in the interactive analysis by putting two factors. One is P factor and Y factor. These are multipliers to the PY data. P factor is always lesser than 1 and Y factor is more than 1. So the springs are softened actually because of the group effect. So that softening is incorporated by applying this P and Y factor in the analysis. One important thing is that the group effect for any group of pile like this tree group, we have to see from different directions of loadings. So in different directions, the interaction will be different from pile to pile. So the most onerous condition has to be adopted in the final analysis. So in case of 3 piles, we normally go for 8 direction loading, and we examine what is the most onerous loading that gives the maximum group effect. So this is a figure from Houghton Coates 1973 paper. You can find out how the stress overlaps actually in case of lateral loading. So basically for group effect analysis also, there are many methods like elastic approach, Midland's interaction, or later adopted by Pulos elastic method can be followed, and separate direction method, which is followed by the offshore industry because it is very convenient for it, and we get the data that is result very well for the pile. And finite element analysis is also possible, but this is not possible for every design. So that's why this separate direction approach, that is using the PY data, is followed for group effect analysis so far as lateral group effect is concerned. So Fock and Coates method 1973 is recommended with some modifications. So that is applied. And there is another method, it was very popular, and some platforms in NGC have been designed using both, that means Fock and Coates also, and Hariharan and Kumarasamy method also. Dr. Hariharan was a veteran in Engineers India Limited, so he along with Mr. Kumarasamy, they derived another method. So I had some study actually. I'll show some results later on how these two methods compare with each other so far as file group effect is concerned. And in both the cases, the P and Y factor are to be applied in the PY data for the group effect calculation. So this first method, the Hopkins method, is a hybrid kind of method. So it combines the elastic approach of pullers along with the PY kind of practical method of lateral loading for offshore files. So the elastic way the factors are calculated, and then it is applied in the PY data. And in case of Hariharan and Kumarasamy, this is the P and Y factors are derived using the elastic, and those P and Y factors are directly applied into PY data. In this case, for Hopkins method, those P and Y factor derivation is a little bit more complicated compared to Hariharan and Kumarasamy. Here we can get direct P and Y factors. Here we cannot get direct. So we have to match these factors. We will show in the next slides. So here we have described, because time is a little bit limited, I will go fast. So here in this case, we have to assume the file as fixed headed, because most of the offshore platform files are fixed headed, and that is what is recommended. And we have to apply the group interaction factors from pullers. This is alpha factor. So increment of displacement because of the group effect from pile to pile between two piles, that is given by pullers for different kinds of conditions, and that is applied in the method. And finally, we get actually n plus 1 simultaneous equations. That means n is the number of piles, and we get n plus 1 equations. Suppose there are 4 pile group, we will get 5 equations. So if we solve these 5 equations, we will get a load in every pile as well as the group deflection. And that is what is to be found out initially. And then we go for the Y factor calculation. So basically, the group deflection is a combination of single pile deflection plus something which is because of the group effect between piles. So this is the basic equation which is to be solved actually, along with another equation. That other equation is that the total load in the group lateral load is the summation of the loads in individual piles. That is the other equation. And these are the equations for every pile. So this indicates the individual pile deformation based on PY, and this is the interactive effect between this pile and all other piles in the group. So we'll get, suppose 4 piles, we'll get 4 different equations of this kind. And P factor is recommended by the Hopkins course as 0.7 to 1 as applicable, and they do not give any formulation to find out the P factor. However, I find from my own analysis that P factor can be very well derived by either by Hariharan and Kumarasamy method, or we can assume a reasonable factor between 0.7 and 1 and go ahead with the analysis. There is no problem. So in case of Hariharan and Kumarasamy method, we find P and Y factor formula directly, and if we solve these things, then we get the P and Y factor applicable for PY analysis. And we apply these factors with the PY data multipliers. So finally, group effect is incorporated like this in the interactive analysis. So the Hopkins method, after we solve the equations which we have shown in the previous slides, then we have to match the Y multiplier with a single pile analysis, assuming the pile head is fixed against this. So the factor which matches that deflection with this Y factor, that is the Y factor to be applied finally. So all these details are mentioned in the paper. So we have to find out this Y factor like this by trial and error, by putting 2, 3, 4 kind of factors and then finding out the matching factor. So these are 2 pile groups which we have analyzed for one paper. This is a 4 pile group, this is a 2 pile group, and as I said, that the group effect depends on the direction of loading also. Suppose there are 3 directions we have shown here. There's a 90 degree, 45 degree, and 0 degree. We find that in this 4 pile symmetric group, the 45 degree angle of loading gives the most onerous condition. So whatever group factor we get with this direction for 4 pile group, that is to be applied. in case of two-pile group, that if we apply the load like this in line, then the group effect will be higher. That is maximum. And if we apply like this, the group effect will be minimum. So the most unless condition for this two-pile group is this 0 degree loading. And based on that analysis for a normally consolidated clay profile throughout the depth of the pile, we analyzed and find the difference between two methods, the Indian method, that is Hariharan and Kumarasamy, 1982, and Proctor Coates method, 1973. We find that for the two-pile group, the difference is quite less for normally consolidated clay. So both methods are quite good actually. And we can simply find out what is the group factor, at least initially, by Hariharan and Kumarasamy method. And then if required, we can go for the rigorous analysis using this Proctor Coates method. For four-pile group also, it is not much different. However, as the number of piles increases in a group, difference also increases. Another thing is that the Hariharan and Kumarasamy method, the group factor is not dependent on load level. That means what kind of load is given. Suppose 50 megaton, 500 megaton, 1000 megaton, kilonewton. All this latter load will have the same group factors. But in case of Proctor Coates, depending on the load level, suppose 50 kilonewton, the factor will be lesser. And in case if we increase the loading, then the factor will be higher. So difference between the two methods in the results will also be bigger if we go for the higher amount of lateral load. So this is the summary actually. So what kind of bending moment increase we got? 26% to 30% bending moment increase we got in case of four-pile group. And in case of two-pile group, we got this. So we can see that difference is very less between two methods for the normal working level of load. And here we have in tabular form, we have shown the differences between the two methods in case of normally consolidated clay for two-pile and four-pile group. In case of two-pile group, percentage difference in displacement is 1.3 to 4.9% only. And in case of bending moment, it's even less, so 0.6 to 1.4%. In case of four-pile group, a little bit more, 4.5 to 14.1% we got, depending on the load level, of course. And in case of bending moment, it was up to 4.3%. So not much actually, depending on that is given the uncertainties in the methods, because limitations are there in all these methods. So difference is quite less for small pile groups in clay. So we are coming to the conclusion of the presentation because time will be over soon. We can say that the current practice of soil capacity assessment is mainly based on the shear parameters of soil as given in the method is given in the main text of API and other international codes. However, the CPT-based methods are gaining more importance compared to the conventional method because of more scientific in nature. And these CPT-based methods are derived based on the latest pile load test throughout the world. So they are calibrated against those load tests, latest load test. Then subfraction of given piles is length dependent in case of CPT-based methods. So for say 100 meter pile length, the subfraction at say 50 meter will be one quantity, and if we increase the pile length, the subfraction will be lesser in that particular depth. So that way, so every different depth we have to analyze the pile capacity again in case of CPT. So it is more cumbersome to calculate the CPT-based pile capacity compared to the conventional method. And we can say that pile-soil interaction is a complex thing because as all geotechnical engineers know that soil is a very uncertain kind of material because it is natural material and the stress-strain behavior is always non-linear for the all working and ultimate conditions. And lateral group effect is generally more important for offshore pile groups compared to axial group effects because after 3 diameter the axial group effect loses its importance. However, for lateral group, it is still important up to 8 diameter. Lateral group effect, as per API recommended method, that is Proctor Coates 1973, combines both elastic and PY analysis, and that is what is being followed for our new designs also in NGC. Difference between results from the two methods presented here is not very significant, as we have discussed in case of NC clay, normally considered clay. If the pile group number of piles is less, say within 4 numbers, then we can definitely see with the Horiaran and Kumarasamy, which is much simpler to calculate, and you can very well go ahead with the design until we get a little bit different value. So that's all. Thank you for your present hearing my presentation, and I'll be happy to discuss if any question is there or any question, anything to be discussed regarding this presentation. Dr. Parthasarathi.
Yes, sir. Rupam, you can unshare the screen, sir, now.
Yeah.
So all the participants, we will post the Google Forms on the chat. Kindly copy that Google Forms, and then if you can kindly fill up that with your contact details, and you will get a copy of this presentation. Amla, can you share that Google form in the chat, please? You can unshare the screen.
Yes, sir. Yes.
Rupam.
Yeah.
And all the
Okay.
participants, kindly post your questions on the chat Q&A session.
Yeah.
So Rupam will go through that, each one of them, and he will try to address it. Sir, are you seeing the chat in the Q&A, Rupam?
Yes, yes.
Yeah.
I have seen it. Yeah, yeah.
Amla, post that Google form link.
Yeah, I'm doing so.
Okay.
Yeah, I sent, sir. I sent.
Rupam, you can answer the question, sir, if you can kindly read through the Q&A session.
Yeah. So right now I have to answer here.
Yeah, you can read the question and then you can answer them.
I can speak and then one can hear.
Yeah, you have the Q&A right on your screen. Left to the share screen, there's a chat, there's a poll, there's a Q&A next to the participant.
Chat. We have seen it here.
Q&A is there.
Questions.
Are you able to see the Q&A?
Yeah.
Yeah, please read the questions and you can answer, sir.
Yeah. One question is that it is asked by Aparna Verma. What's the difference between partially plugged and plugged pile? Partially plugged and plugged pile. So this is related to axial capacity. So it is right that pile may not be fully plugged and it may not be fully unplugged also. It may be partially plugged. So in case of CPT-based methods, if we go into details of the method, we can find out that. However, it is absolutely certain that for the long-term capacity of observed piles, all piles are fully plugged. So there is no question of calculating the partially plugged pile. I think this is all right for this question.
Yeah, I think so, sir. I think.
Yeah. So we have to go for the plugged capacity for the static long-term capacity. So Wood also gives that recommendation that you examine whether it is unplugged or plugged, not the partially plugged. But during driving, it may be partially plugged also. In many cases, it happens. So that's why the soil plug inside the pile is not full. It may be less 90%, 80% also sometimes. That indicates that in certain segments it was plugging. In certain segments, most of the segments, it is driven unplugged. That's the answer. So you can, sir, can we get the presentation of this? It will help for the research. Okay, no problem. I will send the presentation to Dr. Parthasarathi, so he can share with the participants. I have absolutely no problem. Okay. Post the material to chat. Which software is generally used for analysis of suction pile? So suction pile software, to the knowledge I have, that there are two possibilities. One is that limit equilibrium method, which can be used. So there is DMB code for that. So it is fully downloadable in the internet, so we can find out. And also, finite element is very much used in case of suction method, because deformation is a big aspect, unlike the observed pile, non-conventional pile. So 3D finite element is the better approach, and that is also used. So both these are possible. For limit equilibrium capacity, we can find out based on limit equilibrium, and for load deformation kind of thing, to examine what is the limit of deformation and what is the loading angle, how it varies with the loading angle, or that means point at which it is tied with the suction anchor. That these things can be examined very well using the finite element analysis. Then next question is, what is average percentage increase in pile capacity due to pile aging effect? Okay, this is also a good question. This is a matter of research actually, but it is very certain that with aging, pile capacity in Excel, it increases. However, the code has not given so far any particular recommendation, that is how much aging we can consider. Secondly, this is a highly complex thing because if the pile faced certain events like very high amount of storm during the life of the structure, so some of the aging effect will be diluted. So that's why it not only depends on the age of the pile inside, it also depends on what kind of loading or how many cycles of loading, what severity it has faced during the lifetime. So that's why there is no particular thing as to what percentage we can increase. However, from my overall knowledge, you can assume that at least 20% or so is definitely increase with age in case of clay. In case of sand, it will be much more actually. But there's no fixed percentage like this. So it's a matter of research still. Hope in future codes will give proper guidance on this aspect. Then another question is here. In CPT-based pile capacity estimation, how is the digital CPT data processed for use in the formula? Yeah. So here in the CPT-based method for sand, only the QC is required, depth versus QC. So we get the digital data from the field. So anybody conducts a CPT test in site, so one can get the digital data. The digital data comes in the format like depth wise, cone resistance, strip friction, and pore pressure. In CPTU, all the three sensors measure 2 centimeter spacing, we get data. And from that data, we have to process the capacity. So I developed my own software actually to process and find out the skin friction and embedding for sand for piles. And we are using this actually for the recommendation of embedding and embedding, especially for the offshore piles. So you can probably use either some programming or in Excel also if possible. Yeah. Then next question is requested to kindly throw some light on vertical and lateral loop testing of piles for higher diameters. Okay, okay. So Dr. Pathasarthi is an expert in the pile that is monitoring and capo analysis. He is highly involved in not only in Indian offshore, but in other offshores like Gulf and Southeast Asia also very much. So mostly for offshore piles, that instrumented piles data is used, and the CAPROC is the software which is used to find out the capacity based on the driving data. And real load test is very rare. There's some load tests are there, but pile diameters are normally less. In Japan, there was Excel load test, so the data made available in the internet. And this data are often referred in the recent papers regarding Excel pile capacity, especially HCPD-based pile capacity. So in offshore, the logistic is very costly, and it is often impossible to place pintless or gravity load kind of thing what we see in the normal onshore testing. So that's the indirect way we find out the capacity. Of course, there are uncertainties there also, but that is the best available way to find out the pile capacity tested based on driving data. Could you please comment on effect of aging and long-term cyclic loading on Excel files? That question I have already answered.
Yeah.
Already answered. So this I will not repeat. Google phone not working. In CPT-based file capacity estimation, how the digital CPT data is processed for the use in the formula?
Yeah, one pair வருதுங்க.
Question. They are just already. Yeah.
So there are some questions, Rupam, also on the Q&A session.
Okay.
There is a question. How have you used the alpha factor for group efficiency by Randolph method?
Group efficiency for the lateral.
Yes.
Actually, Punas is recommended. Punas charts are recommended. So that Punas factors are what is recommended by the Poct and Post method. However, Randolph has given formula, and then maybe very close to plus alpha factors.
Is the question, is it common to perform soil block analysis for pile groups under axial and lateral loads?
Lateral load, it is not a block analysis. We do not carry out like this. For lateral load, it is based on the Py modification by factors of P and Y.
There are some questions on the Q&A session. So one is that the piles are designed statically. What is the key parameter for dynamic design?
Dynamic design, I will not be able to answer this thing because dynamic loading comes during driving only. So that drivability analysis is carried out to examine the safety of the pile, because of driving, it will there is the hammer will apply dynamic stress on the pile, and that stress is examined along with the stick up related stress. So the API recommends that that stress should be limited to yield strength or 90% of yield strength. So if that check is done, so for our offshore design, this is sufficient. And during driving, it should be safe. During stick up, it should be safe. And during lifting also, lift analysis is also carried out. So there is an impact load during lifting. So that is also analyzed because segments are very long. There will be many moments in stress. So that is what I can answer.
There's one question here. To avoid punch through of pile, how far tip should be above sand clay interface? Maybe 3 times.
Yeah. That is given in the API. At least 3 times diameter of the pile, outer diameter. That much it should be above the clay layer to mobilize the full strength of the sand layer.
So during pile driving, full plug formation is practical for a higher diameter for greater than 96 inches.
It may be possible, yeah. It may be possible. And it is not expected actually. If the driving is done with quite sufficient energy, then it is not expected that the pile will plug. But it may be possible, yeah.
There is one question, how to calculate cyclic effect on long-term capacity? Cyclic effect on long-term capacity.
Cyclic effect on long-term capacity, there are actually parameters, that is, there are charts available based on which we can calculate. I will not be able to say it very well in this forum because I have not done it, but I know that there are charts based on this number of cycles, etc., how the degradation capacity is to be accounted for. So, a better explanation can be got from some other expert.
Yes, sir. I think with that, we can conclude the Q&A sessions. For all the participants, if you can kindly fill up the Google Forms, you will get the a copy of these presentations. So now I will hand over the mic to our Secretary of the IGS chapter, Professor Anbalgan, for a simple vote of thanks. Over to you, Anbalgan.
Yeah. So thank you, Dr. Parsardi. And also, first I heartily thank Sri Rupam so accepting and delivering this lecture. So it is very interesting. About 200 people actually participated in average. And moreover, this offshore, many students who are working, they are keen on your PPT and then your calculations kind of things. So we are highly thankful from our society. I also thank all the participants to logging on Saturday evening and with us on this webinar. So and also I thank Amala and then also Dr. Parsardi to initiate this. So we expect a similar kind of more seminar. So all the participants, as we said in the Google form, you please go fill your Google form, give the feedback, and also we will share with you the recorded video where with the PPT and his voice, where you can get some clarification in the future also. So with this, we close this the session. If you have any clarification further also, you can write to Rupam or to the IGS Bangalore chapter. So thanks one and all.
Thank you.
Yeah, thank you, Rupam, and thank you to all the participants. Thank you very much.